Okay, then I shall get started. So yes, I wanted to talk about GQL, the ongoing effort to standardize the next generation graph query language. We already got a lot of details from Keys on the background to the standardization process and time and all these things. So I will not be getting into those topics. What I do want to talk about though is a little bit the background, how GQL came about, as hopefully is understood by now, all this is
Stefan, we have
progress.
Sorry, Stefan, we have audio issue. Let me kill your video stream. Maybe that will help. And please continue.
Okay. Yes, so all this is still preliminary and still subject to change. By the growing adoption of property graphs, I think it should go without saying, but it's always good to remind people that property graphs are the fastest growing segment of the database industry by far. And the other aspect that made all this possible was, of course, the commonalities between existing languages. Really kicked it off as the GQL manifesto that was asking for the creation of such a language, and that was received really positively by the industry. So what are these commonalities? Well, one commonality, of course, is a property graph data model. All the existing products have, in some shape or form, essentially labeled nodes and edges with properties, right? Usually directed, sometimes undirected, right? But there was sufficient commonality in the database to make such a standardization effort possible. The other big topic is visual graph pattern syntax, which is highly intuitive. Actually, a long-time SQL professional once called it the best syntax for describing drawings that was ever invented, right? While it has a precursor in the literature and academia, of course, it was massively pioneered by Neo4j, who was were the first to apply it to property graphs, and then, of course, it made its way into OpenCipher. The good thing about graph pattern matching, it's not only applicable to pattern matching, but you can also use it for things like DML or DDL, or even in serialization. And to just give a brief hint at that, right here, we have a graph schema depicted as basically an ER diagram kind of thing on the left, and on the right, we see similarly represented this graph through pattern matching syntax, right? That essentially shows which kinds of nodes can be connected to which kinds of edges. So what are the goals of GQL? It's an industry effort to define a universal property graph query language. It aims to establish graphs as a primary data model, which raises the level of abstraction, right? And of course, to the side will enable things such as graph views and graph transformation, things that are today not commonly available in commercial database products. It aims to be backwards compatible with existing languages, applications, and skills. It aims to be a query language for all, for different kinds of user groups, graph experts, SQL users, programmers, analysts. It, of course, aims to grow the property graph space in a way that integrates into modern technology stacks, right? We're using Unicode, IEEE float, ISO 8601 temporal data, things like that. And of course, it wants to be a standard that is easy to learn, use, teach, implement, and evolve, right? That all sounds hopefully good. What are the features that we intend to target? Well, at the baseline, requests are executed in a simple request response model. We have flat asset transactions bound to a session. Then, of course, the key feature is shared with SQL PGQ, support for graph pattern matching with joins, disjunction, nesting with predicates, variable length patterns, shortest path patterns, path bindings, different matching modes, label expressions, right? And in the interest of time, I cannot get into the details of this, but it is a very exciting topic on its own, right? Of course, GQL will have data querying and data modifying operations. It features a hierarchical catalog for accessing multiple graphs in the same query. It aims to support graphs with and without a graph type, or also called a graph schema. It is a composable language with support for user-defined procedures written in GQL itself. It is on the technical level compatible with SQL by providing things like predefined atomic types, expressions, uses similar standards mechanics in many places. And then, of course, it wants to go beyond by supporting things such as parse, collections, and record types. It can return both scalar and tabular results. And the ultimate goal here for GQL is to go even past that and enable things such as graph composition and graph projection and returning graphs to the client. Okay. Just briefly, how does it look like currently? So here we see a lot of the features. A typical query will not use all of these features here. They're shown for completeness. So here in the first item, we set a session parameter in the session set. In the second item, we start a transaction, similar syntax to SQL. Then in 3, we see a typical GQL query that can start with an optional preamble for setting implementation specific settings. For example, here we select a GPU-based runtime. Then the real query starts from social graph. So we select a graph from the catalog. We perform a pattern matching operation that finds friends of a friend from P to F, right? But we insist that the age of the friend shall be larger than the age of the person, and that the friend is from some country that is specified via some kind of request level host parameter. Then we materialize those edges with an insert statement. So here we see a use of visual pattern matching in DML. And since GQL does support reading after writing, we return the edges edit by performing a simple aggregation, right? Then in item 4, we commit our transaction, and in item 5, we end the session. Now this uses the top to bottom return style that is used by OpenCipher and basically virtually every programming language in existence. GQL aims to also support select style syntax, and we here see an example query of that. It should look very familiar to everybody who's ever read SQL. We have a typical select. Then we go on with from sports graph. Here the from selects a graph. Then we have the same match clause or similar match clause to the query we had before. And then we perform aggregation, post filtering after aggregation, and ordering and limiting to determine the result. Last not least, as a third example query, I want to show a multigraph query that shows a little bit the compositional aspects of the language. So here we first start with a nested subquery, again in top to bottom order. And then inside the nested subquery, we perform a pattern matching where we find followers from Twitter and produce a tabular result that we then union with followers from Instagram in another tabular result. And then due to top to bottom composition, the union of those two subqueries feeds into the bottom part of the query where we look for customers that have the same email, then these two sets of followers that we identified from different graphs. And then we return some kind of result here. Yeah, I already spoke a little bit about pattern matching. Yeah, the details are complex and beyond what can be done here in this talk, but maybe also to look a little bit at how it looks like. Here's some syntax examples. We have complex label expressions with conjunction, disjunction, nesting, and negation that goes beyond what you can currently do in OpenCipher, which only has conjunction in this position, right? So you can ask for persons that are additionally either labeled as employee or intern. We have a parse pattern union operator, which is a form of disjunction between patterns, something that, to my knowledge, no current product has. We have, of course, joins, which in pattern matching are always expressed implicitly through the sharing of variables. Transitive closure, very important for expressing variable length patterns, can also be used with lower and upper bounds. We have nesting, a frequently wanted feature in pattern matching. So basically, you start with a pattern and then you have a more complex pattern that you can repeat. And notice also that inside the nested pattern, we can apply predicates as well as, and that's not shown here on the slide, also we can do sub-aggregation. We have parse binding. People who know Cypher should be familiar with that idea. So we can return parse. And then, of course, there's more. There are modifiers for controlling the semantics of matching to do things such as shortest parse matching. Cheapest parse matching is not yet in PGQ, but that might happen, I think. you'll see, and of course, different nodes and edges, semantics, or sometimes also known as node edge isomorphism. So where are we with the standardization effort? We have, so the W3 standards documents come with an annex of issues that yet need to be resolved, which can be quite verbose. And so the document is way over 600 pages. But if you cut that off, then actually the standard is about 500 pages currently. It has been initially editorial drafted by Stephen Cannon, who's the associate editor for GQL, and myself. And the group is currently undergoing a process of piece by piece reviewing and reworking features in the editorial draft. Areas we have already covered include a lot of the pattern matching functionality, the execution model of the standard, the overall environment in which everything executes. People familiar with SQL might be aware of the concept of a SQL environment. GQL has a similar thing. The GQL catalog that I briefly mentioned, the graph data model, and also basic graph schema facilities have already reached consensus. We recently accepted a substantive paper that settled the topic of predefined data types. Now the focus of the work is shifting more towards query structure and data querying statements. We saw in the last W3 meeting, for example, a paper on filter, and also ongoing work is happening on the type system, which needs to support both schema-less and schema-full operations in the backdrop of a standard that reuses the mechanics inherited from SQL. So that's quite a challenge. And then, of course, there's more left to do. DML, while already quite specified in quite some detail, needs further work. From the standardization group, DDL needs a bit of work. There are some issues to be resolved, expressions to be reviewed, and I think we will still also cut down a little bit on size and remove some features and postpone them for version 2 in order to rather have a complete and thorough first draft of GQL available timely. Yeah, and as I mentioned, I'm not getting into that here in great detail. Of course, that's by far not the end. Keith already indicated that we have an interest in cooperating on geospatial topics maybe in the future. We have a lot of ideas and thoughts on how to incorporate graph projection and graph views into GQL. So this is the beginning of a long series of future GQL versions towards which you're working. If you're interested in all this, Peter already mentioned it, right? Use the opportunity to gain access to the documents via the LDBC to track, or of course get involved in the standards effort yourself. And with that, I hope I haven't unduly spent my time. And back to you, Peter.
Thanks, Stefan. Yeah, we are slightly over time, but we could take a minute or two for questions and then have a 5-minute break. So are there questions?
Yeah, I have one question. Thanks, Stefan, for the presentation. Talking about this algebra of GQL, do you support also these paths with negations in GQL? Like if I want to go from this city to this city without passing like some paths or like some cities?
I think that can be expressed using existential, or that will be expressible using existential subqueries. I think through that way you may achieve that.
But not in a direct way, right?
Not in a direct way, no. At least not currently.
Okay, thank you.
Yeah. But keep in mind that existential subqueries can also be nested, right? So I showed you nesting with a where on the inside. So there you could very much have a where not exists, right? So yeah.
Thanks.
Are there other questions? Well, if there are no other questions, then we do indeed have time for a coffee break. So, so thanks, Stefan, for your talk.